Organic Chemistry Review.
By Jamie McColgan and Kate Gaudet.
Organic compounds.
What are they made of?
They must contain carbon and hydrogen, but may also contain oxygen, nitrogen, and other elements.
Where to find them on the periodic table?
Tables P, Q, and R.
Hydrocarbons.
3 major types: alkanes, alkenes, and alkynes.
Organic nonpolar molecules containing only carbon and hydrogen.
They have low boiling points, which means that they decompose fairly easily.
Because of the polarity of water and the nonpolarity of these molecules, they are generally insoluble in water because light dissolves light.
These have poor ionization and react very slowly.
Nomenclature.
Hydrocarbons and other organic compounds are named based on the number of carbon atoms they contain.
The following prefixes are used when the organic compound contains the corresponding number of carbon atoms.
Meth 1,
S2,
Pro3,
But4,
Pent5,
Hex6,
Hep7,
Oct8,
Non9,
Dex10.
Alkanes.
Saturated hydrocarbons mean they contain many hydrogen atoms. This is because they only contain single covalent bonds.
They have lower boiling points.
They are part of the homologous series.
Follow this pattern for molecular formula, N representing the number of carbons present, Cn, H2n plus 2.
To name, first name the shorter chains using guidelines above ending in YL, and which carbon it is attached to, meaning the number.
Then name the longer chains ending in A and E, except for the latter ending. This is true to all compounds of homologous series. Always name by using the shortest chain.
If there are 2 of the same length with shorter chains, use the prefix di. If 3, use tri, and if 4, use tetra.
Examples: 2-methylpentane,
2,2-dimethylbutane,
2,3-dimethylbutane.
alkenes.
Unsaturated hydrocarbons, meaning that they do not contain many hydrogen atoms. This is due to one double covalent bond between carbon atoms.
Higher boiling points than alkanes, but lower than alkynes.
Part of a homologous series.
Longest chain ends in ene when naming.
Follow this pattern for molecular formula, N representing the number of carbons present, Cn, H2n.
Directly before the last or the longest chain, insert the number carbon the double bond is on.
Examples: 3-heptene,
2,2-dimethyl-5-octene.
alkynes.
Also unsaturated due to a triple bond between carbon atoms.
Highest boiling point in the homologous series.
Longest chain ends in yne when naming.
Follow this pattern for molecular formula, N representing the number of carbons present, Cn, H2n minus 2.
Directly before the last or the longest chain, insert the number carbon the triple bond is on.
Examples: 3-pentyne,
2,6-dimethyl-4-octane.
Other organic compounds found on Table R.
Halide or halocarbon, alcohol, and ether.
Halide or halocarbon. Indicate which carbon the halocarbon is attached to using a number. Next, add the prefixes given in the functional group and name the hydrocarbon.
Alcohol. Indicate which carbon the functional group is attached to. Use nomenclature previously given and add LL.
Ether. Using nomenclature, name the carbon chain before and after the oxygen atom. Add YL to each, and at the end, add the word ether. Name the shortest first.
Aldehyde, ketone, organic acid.
Aldehyde. Using nomenclature, add ANAL to the number of carbons it contains.
Ketone. Write the number carbon the oxygen atom is double bonded to. Using nomenclature, add anone to the number of carbon it contains.
Organic acid. Using nomenclature, add anoic acid to the number of carbons it contains.
Ester, amine, amide.
Ester. Using the nomenclature, name the carbon chain before and after the oxygen atom. Add YL to the end of the shorter chain, add anoate to the end of the longer chain. Name the shortest first.
Amine. Write the number carbon the nitrogen atom is bonded to. Using nomenclature, add anamine to the number of carbon atoms it contains.
Amide. Write the number carbon the nitrogen atom is bonded to. Using nomenclature, add and amide to the number of carbons it contains.
Alcohol.
Flammable and combustible.
Liquid at standard temperature and pressure.
Small alcohols are polar and dissolve in water.
Very toxic.
Made by fermentation. There are 3 types.
First degree. OH is on the end of a chain.
Second degree. OH is in the middle of a chain.
Third degree. OH is across from a branch.
Organic acid.
Only organic electrolytes that conduct electricity.
Organic reactions.
Fermentation. There must be no oxygen. Yeast/zymase enzymes are needed. The reactions are glucose and the products are ethanol and carbon dioxide.
Esterification. This is comparable to dehydration synthesis. Water is removed to form an ester. An alcohol and an organic acid are the reactants, and an ester and water are the products.
Combustion. This reaction is highly exothermic. The reactants are something organic and oxygen gas, and the products are carbon dioxide and water.
Substitution. Replaces a hydrogen atom with a halogen. Members of the homologous series and a halogen are the reactants, and the products are a halide and an acid.
Organic reaction.
Addition. This breaks a double or triple bond, letting something be added onto it. The reactants are an alkene or alkyne and a hydrogen atom or halogen. The products are an alkane or halide.
Polymerization. Monomers such as amino acids, nucleotides, sugars, and 1 glycerol and 3 fatty acids come together to form proteins, nucleic acids, carbohydrates, and lipids. The reactants are monomers and the products are polymers.
Saponification. Heat is needed. This is usually used to make soap. The reactants are an ester and a base, usually NaOH. The products are ethanol and ethanoic acid.
Types of formulas.
We are going to focus on 3 different types of formulas. They are structural, empirical, and molecular.
Structural formulas show what a compound actually looks like if it were to be drawn on a one flat surface.
Molecular formulas list the number of each type of atoms in the compound. This is done by writing the element symbol, and then the number of atoms that the element is as a subscript.
An empirical formula is basically a simplified molecular formula. You take the greatest common factor as a subscript and divide each subscript by that. For example, a compound whose molecular formula is C2H4 would have an empirical formula of CH2.
Isomers.
Isomers are compounds with the same empirical and molecular formula, but a different structural formula.
Isomers have different properties and shapes as well.
Benzene.
Benzene is also a type of hydrocarbon. Benzene is a cyclic compound, meaning it is fully enclosed or connected.
Every other bond in benzene is either a single covalent bond or a double covalent bond.
These bonds are constantly moving, which makes benzene so special.
IUPAC.
This stands for the International Union of Pure and Applied Chemistry.
All of the naming systems that we have taught you so far have been created by IUPAC. That is their IUPAC names.
Some compounds have names other than their IUPAC names as well. For example, methanol is also known as formaldehyde.
Environmental issues.
Many dangerous substances, known as fossil fuels, are made of organic compounds.
Fossil fuels may come from waste such as burning gas.
These fuels make holes in the ozone layer, which lets more sunlight come through the earth.
The extra sunlight can result in an increased amount of skin cancer among humans, increased global temperatures, melting of the polar ice caps, and rising sea levels.
To help prevent further damage, we must stop burning so much oil and wasting so much energy.
Credit.
Jimmy McCullough.
Take what?